Hello everyone, today we're going to talk about something completely new, very interesting. I have mentioned these kind of mechanisms before in the past: intrusion detection and intrusion prevention systems. So basically I want to talk about, eventually we're going to get to Snort as the one that I picked to talk about today, because it's the one that I kind of know the best, and I think it is also one of the more easy ones to start with, because it's very easy to create rules for, and I must say that it doesn't really require a lot. It does require you to do some command line stuff, but in the end, you know what is in command line these days. And if you're watching my channel, and I'm not really thinking that you are afraid of doing some command line work. So let's just get started and talk about what is this IDS and IPS really all about. Alright, so first of all, I'm just gonna talk about that you have this picture here down below. You have the internet, which is commonly categorized as the untrusted space. And you have some sort of firewall, and then you could have somewhere in between that, before the firewall or after the firewall. In this case here, it is after the firewall. Then you place your IDS right there. Now, if you place your IDS right here, or the IPS, and Snort is both the IDS and the IPS, so you might ask, but I said IDS, but yes, it is also IPS. It depends on how you set it up. I'm gonna get to that later. So if you set it right here on this line here, on this cable, it is a physical cable, then it's called network-based IDS. So if you, instead of that, have it installed in some sort of computer, well, that is a host-based IDS, and that could be it could be some host just installed. It could be some host that just work on the computer. So it could be anyone. But there are two different types, and this is the most commonly discussed types of IDS and IPS. At the end of the day, it's just some rules you set up, and those rules are going to try and detect and protect your network. So when we talk about the first line defense, it's when you see this as the demilitarized zone. This could be like this here, the invisible triangle that I'm doing with my mouse right now. The demilitarized zone, basically meaning that the idea is put there. So if it's put there, it is the first line defense combined with the firewall, whatever router configuration there is in this particular router, of course. An IDS is not really meant to do deep packet inspection. When I talk about deep packet inspection, I'm talking about that you can look in the actual payload. At the end of the day, the IDS we're going to look at is more or less looking at some part of the payload, but it's very signature based, so it's very static, I would say. And even though that you can find a lot of community rules for many IDS, and you can download free online, it doesn't really mean that it's going to be efficient, because let's assume you have 10 rules. You're gonna say these 10 types of SQL injections, I'm gonna block that, But then again, how many types are there of SQL injections? Have you ever seen a file that's used for fuzzing, and then it just run through 1,000 different types of SQL injection or cross scripting or whatever to try and see if there's something that's going on, if you can make it bug. So the IDS will not really filter on everything. It's just gonna take the very basic stuff. So it is the first line. It's gonna catch all the script kiddies more or less, and then again, script kiddies are getting really good these days because of the tools being generated for them. So SQL map, for example, talking about SQL injection, is a really good tool. And I'm pretty sure that you can find some module for some, nmap or whatever, or Metasploit trying to evade and encode or whatever to try and get through the first line defense. So let's get on. As we also talked about, there are two types of IDS. The first one is a host-based, and the second type is the network-based. Now, the host-based is a host-based intrusion detection system is fixed on a client computer, and the network-based is a system that it inhabits the whole network. So that is why you called it a network-based, because it is protecting the whole network. So you could probably ask the question: should the rules that is put on the host-based and the network-based IDS be the same, or should the host-based be more, based on the actual host that it's installed on? And you could probably ask the question like, but why don't you have both? We could do that. Let's assume we have it. So the network-based IDS is more general, more like SQL injection attacks and cross-scripting, cross-request forgery. Yes, that's difficult to detect IDS, so maybe just cross-scripting and the SQL injection for now, or maybe some other thing. It could be also just detecting that root is logging in. That is also possible. So basically, you could do that. But then on the host-based, it could be like the first host here is also contains a MySQL server. So you can maybe try and detect for some MySQL traffic on a specific port 3306, I think the default port for MySQL is. And yeah, you could definitely do that, but depending on how advanced you want network-based IDS, or how long would it take to verify the traffic? Because you're gonna think about this. If you have an intrusion detection system verifying traffic that is flowing inside of your network, it has to run through all the different kinds of rules specific to the type of traffic. So let's assume you have 2,000 different types of traffic that is related to that particular port that the traffic is incoming, to. So all the 2,000 rules have to be checked every time. So that's going to take some time. What if you're having 5,000 requests every 10 seconds? Then that's going to be 5,000 times 2,000. That's 100,000 different kind of rules. And basically that's really not going to... 100,000, isn't it like even more? It doesn't need the math. You know the math. So yeah, you need a really fast computer, and this is also why I suggest that you do IDS to a certain level, depending on how fast you can get your computer. 72 cores, 100 cores. I don't know how many gigabytes, terabytes of RAM you need to do this kind of things, but depending on which company you are, this can be very very expensive first line defense to just have in your network. So how does it work really? Well, we did talk about it, that it discovers anomalies that catch hackers before they real harm done to our network. But yeah, how's that done? And how much can you detect? Anomalies is in most IDSs static rules. You can get some that is, I assume you can get some that is hooked up on some regular expression, but that's just gonna take even more time. So, as the first line defense, it's not really gonna catch everything. Of course, you need to make sure that your website is mitigating SQL injection by using prepared statements. Of course, you're going to make sure that your systems are up to date. Of course, you're going to make sure that the password chosen for whatever accounts are long enough and complex enough. Of course, you have to make sure that default ports and users and not used services are disabled, it's just like that. But not all remembers that, so it's basically just first line defense before you enter all your other nodes. This is how it works, really. So I wouldn't really, I would never rely on an IDS for, this whole security of the system. And that is something that I've seen, some companies do. They create some sort of IDS that is, that is the line defense for the whole of our web application, because our web application was created back in 1903, and the programmers are dead, and our code is insecure, and it's written in the first version of PHP, and it's like, whoa, the story gets worse and worse, and it's like, okay, so we're gonna slap on, a million rules of whatever anomaly-based rules, and then put it into some IDS, and then hope that everything goes well. Yeah, I'm not really sure where to start. Just don't do it. So you can say that the functions of the IDS is that it provides some sort of support for the user. The type of support could be, well, it kind of go hand in hand with, it could create some log files, and when it creates some log files, administrators can verify the log files, and it could also generate some alarms, if some security breach is detected, or at least a try of a security breach. But it could also block traffic. So this is where the IPS part, intrusion prevention systems, come into play. So if you're using, let's say, Snort, which is an IDS, it can also be an IPS, because you can block traffic. You can also, drop traffic. You can lock traffic. You can alert on traffic. You can do nothing. You don't need rule, but basically, yeah. So there are many things you can do. I'm gonna show some few rules later, and we're gonna see what I mean. And advantages is that you can monitor a lot of standard stuff coming in. You can say that it keeps tracks on all incoming and outgoing traffic if you configure it that way, and it can detect many different kind of attacks or malicious use or whatever you're gonna make it detect. And this is really good because it just stands there, and a lot of stuff. Let's say you have had some botnet issues in the past, or malware issues, making lots of requests to the internet, DNS requests and whatnot. Then you could basically say that this kind of DNS request at this website or to this IP, we're gonna either block it or log it or whatever we're gonna do. So yeah, this is just some of the reasons, and of course more could be found, but I guess from what we already talked about, you should definitely have a really good idea about what the IDS can do for you. And just to talk about some actual issues with an IDS is more or less what you see here, the confusion table, as we call it. Like, you're gonna say like a false negative, true positive, false positive, and true negatives. And I think I'm gonna put it into the picture down here. We have your fraud, and sometimes along the line, let's pitch into the right one here. You're gonna say that all the blue dots, that is just in the gray area, that is legitimate activity. It could be any kind of activity, it doesn't really matter what it is, just to prove a point, just to discuss a point, to raise awareness to the point. And sometimes you could have a blue dot falling into this small, part of the sphere you have right here, or the circle. And that's going to be a false positive. So it's not 100% detecting, or you could say that some fraud could be a false positive, basically meaning that that's gonna go in and do real harm. And the quite opposite is happening on the left side of the bar here, that you can have a lot of true positives, which is legitimate activity, but it just looks weird. So how would you do that? How can you make sure that this is not happening? How can you make the circle less of size? And depending on the complexity of your traffic and the complexity of your system, it's not really possible or feasible that maybe you can make it less of size. This is also just a figure to explain what true positives and false positives is, and false negatives and true negatives, really. But that's basically it. And there are other ways of showing it. I'm not going to do the same talk with the two pictures. It is the same. This table here, I think, is explaining it really nice. So you're really going to make sure that how many false positives do we have? Does it matter for the security or everything on the left side if we block true positive activity, legitimate activity? Then that of course not good. However, the most of the activity we have is considered good, but there are different ways for us to construct a package of traffic that's gonna be accepted. So yeah. Anyways, most IDSs is rule-based, and we see here on the example Snort rule, it's just a rule, it's a one-liner, but it couldn't be on one line, so it's a one-liner. It basically, you can say that if it detects, without going into details right now, because I'm going to do that later, it looks for content in the HTTP traffic, looking for 1 = 1, because many SQL injection attacks contain the 1 = 1, or the very basic one, the script kiddie ones does. So what if that was replaced by 2 = 2? Well, then you would probably have to copy paste the rule and create another rule, same content. However, well, not the content option, but you're gonna replace that as 2 = 2, and then you have a 1 = 1, 3 = 3, 4 = 4, and so on. So yes, this is what I mean with rule-based, and you might think this is quite stupid. I agree with you, but it is made to be the fastest. The fastest way to detect stuff is to be specific. The more abstract you become, there's no issues. You can create any system that just detects, numeric = numeric. You can do that, but it's just gonna be another regular expression, gonna require even more process power. And you might want to ask yourself, for the first line defense, is it that important? Yeah, that could be up to you. There are different kinds, and I just made a Google, I've look at the link if you wish to. You can basically just go and type different types of IDS in Google, and it's gonna find lots of different kind of websites. I just picked one, and I know you cannot click it, but it's just to show that if you really want to do it, wisdom plexus as a keyword, and then type different types of intrusion detecting systems, IDS, and press enter, you're gonna find the link. One that I'm gonna basically talk about is Snort, the one that I know. I'm gonna say it already now. I haven't really used an IDS outside my teachings, but it's okay in a way. Yeah. So let's talk about Snort and what that is and rules and stuff. Now, as we already talked about, Snort is the ideas, and in the end of the slideshow, I'm going to give you a link to the web page with a quick installation guide and stuff like that. But you're going to have to do some more research. Any rule in Snort looks like something like this. So the very first one is the action, so an alert. It's not going to block the traffic, but an alert. And it's going to be alerted to the. I think it's going to be alerted to the console. You can also supply the protocol. It's going to be TCP traffic. The source address is any source address from the outside, port 21. So that sounds like some traffic on port 21, which is commonly used for FTP. However, I have seen some software uses for other things, but more like malware. And the direction is flowing from source addresses from the outside to the inside. However, the source address doesn't have to be external. It depends on where your IDS is. If it's set inside, with different kind of inside traffic, then it could be a local IP as well. But in this particular case, it is it's anything. Its direction is inside to one specific IP address that's gonna be listening on any particular port. And the actual message inside of this would basically just say that the TCP packet is detected, and the SID number is just a number that identify which kind of rule it is. So it could be, in this case, it's 1,000,010. That is the rule number, and the next one could be 1,011,000 and 12 and 13 and so on. So this is one of the examples of a Snort rule. A second one could be something like this, where we're using variables inside the rules, and $telnet server should be a variable that is inside your configuration file in Snort somewhere. So that could contain many different kind of telnet servers. The same for external net. It could be many different kind of IP addresses for external networks. The aim of this rule is to detect a root login on telnet. Now, the reason it is not blocked is because that we are having the alert as the actual action for the rule, and since we're using TCP to connect over telnet, and the content we're detecting is login :root, this is an actual detection for root, and it's gonna be on established connection. So basically that means that it's after the three-way handshake have been made. So that's really what this rule is doing in all of its So third rule is just another way to explain some things. The first word is a syntax based, and the second word too, and so on. So you can basically read that it is also possible to detect encoded traffic. In this case here, it's hexadecimal traffic, and depending on I'm not really sure what this means, but it means that some mount D access is made and you can be alerted. So if let's assume that you have some sort of login to some specific type of service, and you just want to make sure that whenever someone is connecting to that type of service from the outside using either a root account or some higher privileged account, you just want to make sure you're alerted, because it is, after all, a very, very high privileged user connecting to the network. And in most occasions it's probably okay, but in 0.001% of the occasions it might be an actual attack, or maybe the username, the password was leaked in some way, stolen or brute forced, who knows, then of course it is really good to have it in a log file. And the actions, as we talked about, the very first one, alert, can be a different kind of things. It can be alert, log, pass, activate, dynamic, drop, reject, and sdrop. And you can basically just read what this means. And I guess if you want to block something and make it an IPS, intrusion prevention system, you're going to use the drop a lot more. And basically remain idle until activated. Oh, not that one. Make IP tables drop the packet and lock the packet. So you're going to have a log it, of course, so lock the packet. So it's a combination of both dropping it and locking it. And if you wish to install Snort and do some, I have some documentation on it. You can look at the Snort official website, snort.org. This is the web page here. It's pretty simple to install. There are some configuration things you need to take care of when you have installed it on your computer. Yeah, I'm using it on a Ubuntu Linux installation that I have on a virtual machine, and it got Snort installed already and configured, and on that particular VM Ubuntu machine you can install Tomcat server, PHP, Apache combination, as a bundle. You can do many kind of things to test the Snort rules, which is really good, because then you can attack your own server in a virtual machine. Just remember to run some netting or something like that, so you can actually connect to your own servers on your own machine. So for this video, just want to talk about Snort, just want to talk about the IDS and the IPS setup, what it is. And I'm definitely going to do more videos about IDS stuff in the future. So this will be just the first one to give you an introduction to the idea, where you're going to use it, how you're going to use it, what's the advantages and disadvantages. So just want to say, see you again and take care.